What you see now is the 35 kV busbar voltage transformer, also known as the PT transformer. Today, we will take a look at the electrical schematic diagram on this high voltage cabinet. We need to pay attention to the drawing style, which is a single limit drawing. The line you see represents the three phases of A, B, and C. The horizontal line refers to the 35 kV busbar. The power comes down and branches off. As you can see, there are two horizontal bars on the front. The upper end of the bar represents the high point voltage of 35 kV, while the lower end represents a much lower voltage induced to power the light and bring it over. The light you see represents the three lights on my high voltage live wire. When our cabinet is live, these three lights can be sensed, and when they light up, we know that the three phases of our cabinet are live, which means the high voltage is live. After the power is introduced, it reaches the double arrow. The double arrows at the front indicate that our PT belongs to the handcart type PT, and the two small rectangles refer to our high voltage fuses. And here, this is our high voltage lightning arrestor. Overall, this part is the most important voltage transformer inside, which is what we usually call the PT. Its main function is like a transformer, transforming the high point into a low point. You can see that there are 4 coils, and the voltage in the first coil is 35 kV. Then it connects to the high side, and its wiring method belongs to the new type of wiring, where we can see that the remaining 3 coil faces belong to the low side. We can see that the wiring method in this coil is also a star type wiring, meaning we can have an open delta antenna. At this point you may wonder, how high is the voltage on the low voltage side? Well, this PT high voltage is 35 kV. Okay, you can see the stars in this coil, which represent the voltage between the phases. Normally, when measured, the voltage between the 100V phase and phase is measured. And of course, this is a new type of wiring, where you measure the voltage between the 3 phases. And the voltage between any 2 phases is 100V. It transforms the 35 kV high voltage into the 100V low voltage, which is used for measurement and metering of some equipment. That's what it means. Okay, we can see that the wiring method belongs to the open delta wiring. The main purpose of the open delta wiring is to collect the zero sequence point when the 3 high voltage phases are operating normally. That is, when there is no fault, there is basically no sequence current, but there may be zero sequence voltage. Once there is a single phase ground fault and an unbalanced voltage occurs, our zero sequence coil can collect the zero sequence point. Once the collected zero sequence point exceeds the safety value, we need to trip the circuit breaker, which plays a valuable role in protecting the equipment. When correcting, it means to correct the power factor once, and its main purpose is to protect this PT. Without this feature, our PT here is prone to burning out, and the main purpose of this momentary effect is to better use the fuses and the fuse.